we are going to discuss the last part of this refrigeration air conditioning for aeronautical engineering. This is the air conditioning system design and duct design. Basically, it is the part which is related with the large air conditioning system design solution. In this part, we will be discussing the different systems and design, their classification, selection of the equipments, then the different type of air distribution system, in which we are going to cover all air, all water, and the mixture. Then how duct, why duct is required, what are the different type of filters, piping, and different type of sensors like temperature, pressure, and humidity control, and few accessories which is used for air conditioning system and duct design. So first, the classification and equipment selection. So for air conditioning system, which is largely known as HVAC, heating, ventilation, and air conditioning system, the main components are listed here. Like first, air plenum and outdoor air control. First of all, we need to control the flow of air, because that is going to affect the entire situation. Then filters, which is used to flow of air. Supply fan, which is used to regulate the flow rate. Then exhaust and relief fan for air outlet. Air intake, then the type of ducts, length, width, all the dimension of the ducts. Then terminal devices, which is at the initial and the end of the duct. Then return air system, which is used to carry out the used air in the conditioned space. Then heating and cooling coil, because when we are using it for large air conditioning system, generally heating and cooling both are preferred. Then self-contained heating and cooling unit, which is placed at the air handling unit system. Then cooling tower, basically it's a centralized tower to cool the entire amount of water. Then boiler, control, water chiller, and humidification and dehumidification equipments. These are the total component or basic component of any HVAC system. In air distribution system, all air, all water, air water, single and central air grading system is going to be the part of classification. So first of all, the central air conditioning or central heating, ventilation, air conditioning system is classified into type of working fluid, which is all air, all water, air water, and some other type of mixture. Basically, this all air, all water system can be further classified into different type of single zone, multi zone, dual duct, variable air volume, fan coil, induction coil, etc. So this is the simple classification, that if we are using central air conditioning system, then which type of system can be used. So if we are using for different and multiple blocks of the building or multiple buildings as well, then it is recommended to use different air water system or mixtures of air water system. The typical example of one of the system of all air system, where the working fluid is only air. So in that particular system, first of all, you need, in this figure, what you need to do, you need to first find out the conditioned room, so where it is located. So it is on the extreme right side of this particular figure. Conditioned room, return diffuser, supply diffuser. Supply diffuser means it is going to supply the air in the room. It is marked by blue, it means it is going to supply the conditioned air. Like return diffuser means it is going to use the stale air or the used air from the room. It is going to supply and supply to the basic system. So as the name suggests, air is used in the media in all air system. Air transport thermal energy from the conditioned space to the HVAC plant. As shown that in figure, the system is processed in AC plant, namely by AHU, air handling units. This AHU consists of dampers, mixing chambers, filters, cooling heating coil, dehumidifier, fan, blowers, etc. So all type equipment are this marked by the pink one, and everything is there, right? Mixing chambers, filters, fan, cooling, heating, everything. So this processed air is then supplied to the conditioned space, blue one. through SAD, supply air duct, which is known as supplied air distribution system. This also consists of ducts, damper and diffusers. Now this supply air, that can be circulated to other room as well, if suppose it is using for multiple rooms or multiple buildings. And similarly, that supply air duct can be used to supply heated air in case of winter, which is the required amount of sensible and latent heat from the conditioned space. Now the duct supplies the air into the space is known as SAD, supply air duct, and the return air duct, which is RAD, which is taking the used to carry out the used air. Now this return air from the conditioned space is conveyed back to the plant, where it again undergoes the required processing and means creating it into the controlled condition and again recirculate to the conditioned space, thus repeating a cycle. This duct from the air from the space plant is called return air duct. Now adequate fresh air is always supplied by AHU to maintain the ventilation and indoor air quantity, IAQ. Otherwise what will happen, we are going to continuously use the same air. So fresh air or the mixing of fresh air is always required as per the ASHRAE guidelines, as standards. Like return air and outside air is required to be balanced in proportion, and the rule is supply air equal to return air plus fresh air. Since fully treated air is supplied by AHU, no further processing of the air is required by terminal units in the conditioned space. So this type of device can be used. Now this CHWS and CHWR, the top part of this particular figure, which is chilled water supply and chilled water return part. So it is basically part where the cooling tower is located. So this particular chilled water supply is connected to the cooling tower. This is another representation of, now in that particular system, HVAC system, the important part is that, or the controlled air, where the filter is located. Carrier is the duct. Generally filter is located. How duct is classified, why duct is for the used to carry the and mixing air zone, which is known in that figure box. There are two diagrams before the mixing box, preheat, cooling, and in diagram A, humidifier. This is basically supply air, not a fan, smooth one. Then return air. It has some, this part will sharp edges, and while diagram B has the smooth edges. So since A has some sharp edges, obviously there will be more turbulent flow, while in B it's smooth edges, so less turbulent flow. So basically it's just example to show how bends and other joints can be avoided in ducting, because ducting means somewhere the centrally air is prepared and that air is supplied to the different zones, different rooms through duct. So the duct design should be perfect so that it should have minimum bends, and if bends are there then it should be smooth enough. Why? Because if you have, suppose one example, 2.5 ton air conditioner, and for that particular high ton air conditioner the nominal air flow should be 1000 CFM cubic feet per minute as per the thumb rule of 400 CFM per ton. So that means the blower has to push about 81 pounds of air through the system each minute. It means it takes work to move weight, the weight of that amount of air. So what work, how we are going to conduct the work? By using some fan. So you can move this weight for free if you move it horizontally, means without friction or without any kinds of resistance. And when some friction is there, then it takes work to move it upward against gravity, or to push it in any direction against friction. So this is very simple fundamental that we all know. So if you take a fan and turn it on, then you will get the maximum air flow. And if you take some same fan and blow the air, the same air in a cardboard tube like in this figure, then because it's a specified space, then we need to work against this pressure that builds up in the space. So if the edges are sharp, will be more pressure will be there. If the edges are not sharp, then less pressure will be there. This is the basic principle of duct design. So there are two factors. First is friction. As the air moves through the duct, it interacts with the surface. The smoother the inner surface, the better is the air flow. The rougher the surface, the more it slows down the air. The second factor is turbulence. This generally arises when you move air through fitting or whenever we turn the air. So with the rigid duct you turn the air with fitting, but unfortunately that's not always the case of flexible duct. Now in duct system design, when air comes out of the air handling unit, several things happens. First is it send various rooms in the house. Suppose we are talking about a household air handling units, then it travel through the different branch and branches of the duct system, which where quantity keep varying, with some gets diverted through different branches to different rooms. So constant supply is the main criteria to regulate the airflow. So each section of the duct, each fitting, each turn of air adds resistance to the airflow due to friction and turbulence. Similarly, some filters are also used, some balancing dampers also used, and they'll add the resistance to the flow. That resistance results in decrease in the static pressure or ultimately the pressure drop. So when we place a blower there to maintain a pressure, then air comes out of the supply band and the pressure also dropped. Sometimes it is also zero. So all these factors are required in this duct design. Another important factor is the filters. There are two types generally filters are used: air filters and HEPA filters. Air filters are further classified air intake filter and clean air filters. So these are the filters we generally see in the household air conditioners, which is generally known as to clean in every 15 days, so that the whatever the contaminants and dust and pollens are inside the room, that should be cleaned out every regular interval. And then HEPA filters. Basically HEPA filters are high efficiency particulate air. So it's a type of mechanical air filter. It works by forcing air through a fine mesh that traps harmful particles, pollen, dander, dust mites, and tobacco smoke. There are so many things. So HEPA filter is basically high efficiency filter, and normal air filters, clean air filters, can be used. So just it is to show that this air, blue air, is having all type of particles in it. Then one filter is used. It will supply you only clean air. We can maintain that how much clean air is circulated. So filters are the part of air conditioning system. Now the piping, because the hot high pressure refrigerant vapor enters the condenser where heat is transferred to ambient air, which is at the lower temperature in the refrigerant. Then inside the condenser, refrigerant vapor condenses into the liquid and is subcooled. Similarly, the liquid refrigerant flows from the condenser to the expansion device. So basically what is happening here, the refrigerant is moving from compressor, condenser, expansion valve, and evaporator, and all these devices are connected through a piping which is known as the refrigerant piping. Okay, and this refrigerant is subjected to high pressure, low pressure, vapor, and also in liquid form. So the cool mixture in last part, the cool mixture of liquid and vapor refrigerant enters the evaporator, and this cycle is repeated. So basically this refrigerant is continuously subjected to different type of conditions. It means that whatever piping which is used should resist all type of fluctuations. Here one diagram, it is shown like this is from evaporator, B, suction line, discharge line, and this line. So these individual components are connected by refrigerant piping for the following condition. One is return oil to the compressor at the proper rate at all operating condition. Only liquid refrigerant enters the expansion device, no vapor. Then minimize system capacity loss, maybe like pressure drop, in fact flow drop, as well as through the different piping and accessories. Minimize the total refrigerant charge and overall cost. So these are the criteria for refrigerant piping. Now apart from refrigerant piping, few sensors are required apart from actuator and controls. So first of all we talk about temperature, pressure, and humidity sensors. So temperature sensor is a device that detects and measures hotness and coolness of the room and convert it into electrical signal. Different type of temperature sensors are like general thermometers, thermistors, RTDs, thermocouples and thermopiles. The details of all type of the sensors I have collected in a Word file, and I am going to upload on the Google Classroom, so a student may find the complete detail of all type of sensors, in fact safety controls as well. So these are the temperature sensor which is used to measure the temperature, and this is the most important sensor in that air conditioning system design. Next is the superheat condition, which is cannot be completely eliminated, but it can be minimized to improve the efficiency. So if you remember the TS diagram, the superheat condition means we are entering on the right side of the vapor zone. So when if we are going to measure pressure and temperature continuously by electronic temperature and pressure transducers at the evaporator, coil outlet and temperature inlet or compressor inlet, then we can avoid the superheat condition. For that, what we need to do, we need to have some pressure transducers which is used to control the superheat. Generally this type of superheat condition is required to be avoided in the industrial air conditioning applications. So where we can measure the pressure and temperature, so these are the points where we can measure the pressure to avoid the superheat. So evaporator, coil outlet pressure, compressor inlet pressure, evaporator coil outlet temperature, compression inlet temperature, and expansion valve flow rate monitoring. This is basically 2 outlet and 2 inlet compressor and evaporator pressure temperatures are required to be monitored continuously. Humidity sensor or hygrometer sensors measure and report moisture as well as temperature. So if normal air conditioning is to be used, then we can use this humidity sensor which can measure the humidity as well as the temperature. So generally three type of humidity sensors are used. First is capacitive sensor. In capacitive sensor, basically the humidity is measured, or relative humidity measured by placing a thin strip of metal oxide between two electrodes. The metal oxide electrode capacity changes with the atmospheric relative humidity. So as the relative humidity changes, it will give the values, and we can measure directly the change in humidity. Second type of humidity sensor is resistive sensor. In resistive sensor resistive humidity sensors, it utilizes the ion in salts to measure the electrical impedance of atoms. So as humidity changes, so the resistance of electron on either of the salt changes. So that medium can be used to measure the change in humidity. Third type of sensor is the thermal sensor. In thermal sensors, two thermal sensors conduct electricity based on the humidity of the surrounding air. One sensor is in dry nitrogen while the other sensor is ambient air. So the difference between two measure the humidity, dry nitrogen and ambient air, where humidity is the part of air itself. In HVAC control system, it is generally distributed across these different type of areas. First is HVAC equipment, their control mainly located in the mechanical room. Mechanical room, which means the centralized room where we are going to control the overall air conditioning plant. So it's a central location where equipment include chillers, boilers, hot water generator, heat exchanger, pump, etc. So on a single platform we can control the all HVAC equipment. Second, the weather maker or air handling unit, where we can control the humidity as well. So it may heat, cool, humidify, dehumidify, ventilate, or the filter the air and distribute that air in the section of the building. So air handling unit control may be separate or may be the part of the single mechanical room. All HU are available in various configuration and can be placed in the dedicated room called secondary equipment room, and may be located in the open area, sometimes at the rooftop air handling units. So the air handling unit may be the part of central air conditioning, or it may install it separately into different rooftops, so that if suppose a large air distribution system is there, then we can control AHU separately for each building, where all the buildings are centrally air conditioned by the centralized plant. The individual room control also depending on the HVAC system design. If we are using individual room control, then it must include fan coil unit, variable air volume system, terminal reheat unit, ventilators, exhausters, and all the measurement device, temperature and humidity device. So this type of controls are used, and some benefits are listed here, like maintain thermal comfort condition, maintain optimum indoor quality, reduce energy use, plant operation, safe plant operation. So if we have some distributed network of controls, it means the overall plant safety will be ensured. Whenever some hazards may occur, then the losses will be minimum. So it will also reduce the manpower cost, identify maintenance problems easily, then efficient plant operation to match the load and monitoring system performance. So these are some of the benefits and criteria also, so that the air handling units, mechanical units and individual room controls can be placed in that manner. General controls in that total control part of this air conditioning unit are fuses, circuit breakers, switches, capacitors, solenoid valves to control pressure, heater, transformers, contactor starters, relays, apart from the compressor and motor, because if we are using large air conditioning system, it means several compressors and several motors will be used apart from different sensors. So these are some of the control systems. Now apart from the conventional heating, ventilation, air conditioning system, few accessories are also used, like smart thermostats. It means it will be like a smart, means it is a programmable thermostat where we can program for different conditions, like if the temperature goes that below, the humidity goes that below, or that a point, then how that all control units will work. If we are using several control units, air handling units for a central air conditioning system, and some building may not operate, like no work have been carried out, then that HU will and this thermostat indicate that the overall temperature is constant, there is no variation, then automatically it will switch off. So basically the programmable thermostats can be also the part of modern HVAC system. Then energy recovery ventilators, it means sometimes the cold air is much more in some zone of the central air conditioning units, so that cold air, or or maybe some winter and heated air, that can be taken to the ventilators and circulated through the air handling units. Also air purifiers are the part of modern accessories of a heating ventilation system, because it purifies air by decontaminate, and instead of using separate air filled purifiers, it will be the part of heating ventilation part, so that the overall cost will be minimized. Then ultraviolet air cleaners, so sometimes these air cleaners are the part of heating ventilation air conditioning system to save the particular building or space through ultraviolet rays. And like dehumidifiers, so sometimes if in a particular system, or the region of the building is in dry states, where the moisture is too much to below the required condition of ASHRAE recommendations, then we can use some dehumidifiers, mist generators, so that some moisture can be added to the environment and the minimum moisturing condition can be created. So dehumidifiers may be oil type, maybe water type as well. It depends upon the type of zone where we are using the air conditioning units. So this brief introduction ends the air conditioning system and duct design. Some additional files are uploaded on the Google Classroom. Student may take help of these notes for further analysis. Thank you.